Good morning, dear students. My name is Farhan Mazhar, and the subject we are studying is Cambridge O Levels Physics 5054. We are working on the revision checklist for this syllabus, and today we have selected topic number 4 from the syllabus of Physics 5054, and the name of the topic is electricity and magnetism. And in this video, we have provided some revision checklist. These include information from the syllabus that you should revise. They don't contain all the detailed knowledge. You need to know just an overview. For more detail, see the syllabus and talk to your teacher. So here we will have, I will show you a table, and in that table, you see the topic number 4, electricity and magnetism. So there are 4 columns, 1, 2, 3, and 4. The first column has the first column are these are the topics you will study. In the second column, you should be able to. Here we have the content in the syllabus you need to cover, and here the third column. You can see these boxes. You can tick in them. You can use the tick boxes to show when you have revised an item and how confident you feel about it. Here, R means red, means you are really unsure and lack confidence. You might want to focus your revision here and possibly talk to your teacher for help. A here stands for amber, means you are reasonably confident but need some extra practice. G stands for the green, which means you are very confident. As your revision progresses, you can concentrate on the red and amber items in order to turn them into green items. You might find it helpful to highlight each topic in red, orange, or green to help you prioritize. So the table cannot contain absolutely everything you need to know, but it does use examples wherever it can. Okay, so we have the topic number 4, electricity and magnetism. So you should be able to. The first topic is simple magnetism and magnetic field. Describe the forces between the magnetic poles and between magnets and magnetic materials, including the use of the term North Pole, South Pole, attraction and repulsion, magnetized and unmagnetized. Describe induced magnetism. State the difference between magnetic and non-magnetic material. State the difference between the properties of temporary magnets made of soft iron and the properties of permanent magnets made of steel. Describe a magnetic field as a region in which a magnetic pole experiences a force. Describe the plotting of magnetic field lines with a compass or iron filings and the use of a compass to determine the direction of the magnetic field. Draw the pattern and direction of the magnetic field lines around a bar magnet. State that the direction of the magnetic field at a point is the direction of the force on the north pole of a magnet at that point. Okay, so then we have you should be able to know that the relative strength of a magnetic field is represented by the spacing of the magnetic field lines. Describe use of permanent magnets and electromagnets. Then we have electrical quantities. The first topic is electric charge. State that there are positive and negative charges and that charge is measured in coulombs. State that unlike charges attract and like charges repel. Describe experiments to show electrostatic charging by friction. Explain that charging of solids by friction involves only a transfer of negative charge. Describe an electric field as a region in which an electric charge experiences a force. State that the direction of an electric field line at a point is the direction of the force on a positive charge at that point. Describe simple electric field patterns, including the field around a point charge, around a charged conducting sphere, between two oppositely charged parallel conducting plates, and effects will not be examined. State examples of electrical conductors and insulators. Describe an experiment to distinguish between electric conductors and insulators. Recall and use a simple electron model to explain the difference between electrical conductors and insulators. Electric current. Define electric current as the charge passing a point per unit time. Recall and use the equation. Electric current is equals to charge divided by time. I is equals to Q divided by time. Describe electric conduction in metals in terms of the movement of free electrons. Know that current is measured in amps, or we call it amperes, and that the amp is given by coulomb per second. Know the difference between direct current, which we call DC, and alternating current, which we call AC. State that conventional current is from positive to negative, and that the flow of free electrons is from negative to positive. Describe the use of ammeters, analog and digital, with different ranges. Electromotive force and potential difference. Define EMF, electromotive force, as the electrical work done by a source in moving a unit charge around a complete circuit. Recall and use the equation. EMF is equals to work done by a source divided by the charge. E is equals to W divided by Q. Define potential difference as the work done by a unit charge passing through a component. Recall and use the equation. Potential difference is equals to work done by a component divided by charge. V is equals to W divided by Q. Know that the EMF and the potential difference are measured in volts, and that the volt is a joule per coulomb. V is equals to its unit, 1 volt is joule per coulomb. Describe the use of voltmeters, analog and digital, with different ranges. So calculate the total EMF where several sources and are arranged in series. State that the EMF of identical sources connected in parallel is equals to the EMF of one of the sources. Electric circuits. Recall and use the equation. Resistance is equals to potential difference divided by current. R is equals to W divided by I. Describe an experiment to determine resistance using a voltmeter and ammeter and do the appropriate calculations. Recall and use quantitatively for a wire the direct proportionality between resistance and length, and the inverse proportionality between resistance and cross-sectional area. State Ohm's law, including reference to constant temperature. Sketch and explain the current voltage graph of a resistor of constant resistance, a filament lamp, and a diode. Describe the effect of temperature increase on the resistance of a resistor, such as the filament in a filament lamp. Electric circuits, circuit diagram and circuit components. Draw and interpret circuit diagrams with cells, batteries, power supplies, generators, oscilloscope, potential divider, switches, resistors, fixed and variable resistors, heater, thermistor, NTC only, light dependent resistors, LDRs, lamps, motors, ammeter, voltmeter, magnetizing coil, transformers, fuses, relays, diodes, and light emitting diodes, and know how these components behave in the circuit. Series and parallel circuits. Recall and use in calculations the fact that the current at every point in a series circuit is the same. The sum of the currents into a junction in a parallel circuit is equals to the sum of the currents that leave the junction. The total potential difference across the components in a series circuit is equals to the sum of the individual potential differences across each component. The potential difference across an arrangement of parallel resistances is the same as the potential difference across one branch in the arrangement of the parallel resistances. Calculate the combined resistance of two or more resistors in series. Calculate the combined resistance of two resistors in parallel. Calculate current, voltage, and resistance on parts of a circuit or on the whole circuit. Action and use of circuit components. Describe the action of negative temperature coefficient NTC thermistors and light dependent resistors and explain their use as an input sensors. Describe the action of a variable potential divider. Recall and use the equation of two resistors used as a potential divider. R1 by R2 is equals to V1 by V2. Remember this equation. Practical electricity. State common use of electricity, including heating, lighting, battery charging, and powering motors and electronic systems. State the advantage of connecting lamps in parallel in a lighting circuit. Recall and use the equation power is equals to current multiply voltage. P is equals to IV. Recall and use the equation energy is equals to current multiply voltage multiply time. E equals to IVT. Define the kilowatt hour and calculate the cost of using electrical appliances where the energy unit is kilowatt hour. Electrical safety. State the hazards of damaged insulation, overheating cables, damp conditions, excess current from overloading of plugs, extension leads, single and multiple sockets when using a main supply. Explain the use and operation of trip switches and fuses and choose appropriate fuse rating and trip switch settings. Explain what happens when a live wire touches a metal case that is earth. Explain why the outer casing of an electrical appliance must be either non-conducting, double insulated, or earth. Know that a main circuit consists of a live wire, which we also call the line wire, a neutral wire, and an earth wire. And explain why a switch must be connected to the live wire for the circuit to be switched off safely. Explain why switches, fuses, and circuit breakers are wired into the live conductor. Electromagnetic effects, electromagnetic induction. Describe an experiment to demonstrate electromagnetic induction. State that the magnitude of an induced EMF is affected by the rate of change of magnetic field or the rate of cutting of magnetic field lines, the number of turns in a coil. State and use the fact that the effect of the current produced by an induced EMF is to oppose the change producing it. This is called Lenz's law, and describe how this law may be demonstrated. The AC generator. Describe a simple form of AC generator, rotating coil or rotating magnet, and the use of slip rings and brushes where needed. Sketch a graph of EMF against time for a simple AC generator and relate the position of the generator coil to the peaks, troughs, and zeros of the EMF. Magnetic effect of a current. Describe the pattern of the magnetic field due to currents in straight wire and in solenoids, and state the effect on the magnetic field of changing the magnitude and direction of the current. Describe how the magnetic effect of a current is used in relays and loudspeakers and give examples of their application. Force on a current carrying conductor. Describe experiments to show the force on a current carrying conductor in a magnetic field and on a beam of charged particles in a magnetic field, including the effect of reversing the current, and second is the direction of the field. Recall and use the relative directions of force, magnetic field, and current. Describe the magnetic field patterns between current in parallel conductors and relate these to the forces on the conductors, excluding the Earth's field. The DC motor. Know that a current carrying coil in a magnetic field experiences a turning effect, and that the turning effect is increased by increasing the number of turns on the coil, the current, the strength of the magnetic field. Describe the operation of an electric motor, including the action of a split ring commutator and brushes. The transformer. Describe the structure and explain the principle of operation of a simple iron core transformer. Use the terms primary, secondary, step up, and step down. Recall and use the equation Vp by Vs is equals to Np by Ns, where P and S refer to primary and secondary. State the advantage of high voltage transmission and explain why power losses in cables are smaller when the voltage is greater. Uses of an oscilloscope. Describe the use of an oscilloscope to display waveforms. The structure of an oscilloscope is not required. Describe how to measure potential differences and short intervals of time with an oscilloscope using the Y gain and time base. So my dear students, this was all from the topic number 4 of the syllabus Physics 5054 of the Cambridge O-levels. And these are revision checklists, and you can use this and check that if your revision is complete, you have done all these topics. I hope this video will help you. If you find this video interesting and useful to you, please share the link of this video with your friends and with your class fellows, with your teachers, with your senior students, with your junior students. When you do this, when you share the link of this video, when you like this video, this helps me to promote my channel. It's a great blessing for me that I can make these kind of videos which can touch the life of so many students around the globe. Thank you very much for watching this video. Have a good day. God bless you all.